In today's video, we will be going over the first 5 questions of the Test of Mathematics for University Admission, TMUA 2023, Paper 1. So, in the first question, we're given that the integral from 0 to 1 of ax plus b dx equals to 1, and also that the integral from 0 to 1 of x times ax plus b dx equals to 1. And we need to find the value of a plus b. So our approach for this question would be to basically evaluate the indefinite versions of these integrals, and then we will use the indefinite integrals to obviously solve the definite integral, and then convert this into a simultaneous equations problem. So let's see exactly how we will do it. So firstly, we have the integral of ax plus b dx, which is equal to a half of ax squared plus bx plus constant. And then for the second integral, we have x times ax plus b dx equals to the integral of ax squared plus bx dx, which is equal to a third of ax cubed plus a half of bx squared plus constant. So now we use this result to solve the definite integral, which is for the first integral, we have a half of ax squared plus bx from 0 to 1 equals to 1, which means half a1 squared plus b times 1 minus a half a0 squared minus b times 0 equals to 1, which basically means that a half of a plus b is equal to 1. So for the second integral, we have a third of ax cubed plus a half of bx squared from 0 to 1 is equal to 1. So that means that a third of a times 1 cubed plus half of b times 1 squared minus a third of a times 0 cubed minus a half of b times 0 squared equals to 1. So that basically means that a third of a plus a half of b would be equal to 1. So we see that we have a pair of simultaneous equations now. It remains to solve for the solution for this pair of simultaneous equations. So we'll just multiply the second equation by 2 and obtain a half of a plus b equals to 1, and 2/3 of a plus b equals to 2. So we subtract the second equation from the first to obtain negative 1/6 of a equals to negative 1. And therefore, we have a equals 6, and solving, we get b equals to 1 minus a half of a, which is negative 2. So the question asks for the value of a plus b, which would be equal to 6 plus negative 2, which is 4. So option F would be the answer to the first question. Moving on to the second question, here we have two equations which are y equals x squared plus 5x plus 6 and y equals mx minus 3, where m is a constant. And we're given that when these two graphs are plotted on the same set of axes, they do not meet. So in this case, what is the complete range of possible values of m? So in order to tackle this question, we need to understand that the meaning of the graphs do not meet is that these two equations do not have a common solution. So basically, that means x squared plus 5x plus 6 equals to mx minus 3 has no solution. So in order to check whether such a quadratic equation has a solution or not, we need to examine the discriminant, which is exactly what we'll do now. Firstly, we can rearrange it a bit so that it becomes x squared plus 5 minus mx plus 9 equals to 0. And if we compare like terms with the form ax squared plus bx plus c equals to 0, we can obtain a equals 1, b equals 5 minus m, c equals 9. So the discriminant would be equal to b squared minus 4ac, which is equal to 5 minus m squared minus 4 times 1 times 9. And in order for this quadratic equation to have no solution, the discriminant must be smaller than 0. So it remains to solve for this inequality, basically. So we obtain 5 minus m squared has to be smaller than 36, which also happens to be 6 squared. So the final question is, what is the range of m such that 5 minus m squared is smaller than 6 squared? It turns out that this is the same problem as determining what is the complete range of m such that when compared with the number 5 on the number line, the number m and the number 5 do not differ by 6 units or more. So that means if we consider 5 in the middle, you can at most extend this by 6 to the right or 6 to the left. So that means the possible values of m are from negative 1 to 11, excluding both ends. So the answer must be A. Moving on to the third problem, here we're given that for any integer n, which is greater than or equal to 0, the integral from n to n plus 1 of fx dx equals to n plus 1. And we need to evaluate the sum of these 5 definite integrals. So let's start from the easiest one, which is in the middle. Here we have the integral from 2 to 3 of fx dx, which is exactly in the form we see above. So we can just read off the condition above, and we can obtain that this definite integral equals to 3. So let's move on to the fourth one over here. So this is the integral from 4 to 3 of fx dx. So recall the following fact. The definite integral from a to b of fx dx is equal to the negative of the integral from b to a of fx dx. So using this fact, we would realize that this value is just a negative version of the integral from 3 to 4 of fx dx, which we know by the fact above to be 4. So therefore this version would be negative 4. So now comes the remaining integrals, which is the first one, the second one, and the fifth one. So how would we find out, for the second one, how would we find out the integral from 1 to 3 of fx dx? So it turns out that the integral from 1 to 3 of fx dx is nothing but the sum of the integral from 1 to 2 fx dx plus the integral from 2 to 3 fx dx, which is equal to 2 plus 3, which is 5. So this one over here is equal to 5. Similarly, the integral from 0 to 3 of fx dx would be equal to the same two integrals plus the integral from 0 to 1 fx dx. So that adds a 1 to the answer, which sums up to 6. So this one here is 6. Now it remains to solve for the final integral, which is the fifth one. And we will firstly calculate the definite integral from 3 to 5 of fx dx. This would be equal to the definite integral from 3 to 4 fx dx plus the definite integral from 4 to 5 fx dx, which is equal to 4 plus 5. And since here we basically just swapped the order of the 3 and the 5, we just have to negate the result. So the result here is 9. So the result we are actually looking for would be -9. This gives the final result, which is 6 plus 5 plus 3 minus 4 minus 9, which is equal to 1. Moving on to the fourth problem, here we want to evaluate this infinite series over here. So it might be helpful to approach this problem by listing out the first few terms of this infinite series and see what we get. So this series starts off by sine of 0 pi plus pi over 3, which is pi over 3, over 2 to the power 0, plus sine pi plus pi over 3, which is 4 pi over 3, over 2 to the 1, plus sine 7 pi over 3, 2 to the 2, plus sine 10 pi over 3, over 2 to the 3, and so on. And recall that the period of sine is 2 pi. And here we actually do increase by 2 pi every time, every 2 terms. So here it is sine pi over 3, and after 2 terms, it becomes 7 pi over 3, which is an increase of 2 pi. And since the period of sine is 2 pi, it basically means the numerator is periodic every 2 terms. So we can rewrite this as sine pi over 3, 2 to the 0, plus sine 4 over 3, 2 to the 1, plus sine pi over 3, 2 to the 2, plus sine pi over 3, 2 to the 3, and so on. And we can regroup the terms to obtain sine pi over 3 times 1 over 2 to the 0, plus 1 to the 2 over 2, plus so on, plus sine 4 pi over 3 times 1 over 2 to the 1, plus 1 over 2 to the 3, and so on. So we know that this infinite series over here, this is just 1 plus 1 over 4 plus 1 over 16, and so on. So this would sum to 4 over 3. And we know that sine pi over 3 is root 3 over 2. So that's root 3 over 2 times 4 over 3. And over here we have sine 4 pi over 3, which is basically just the negative of sine pi over 3. So that's negative 3 over root 3 over 2 times this infinite series here, which is just a half of the previous infinite series. So that's a half of 4 over 3. So the final answer would be 2 root 3 over 3 minus a single root 3 over 3, which is root 3 over 3. So the answer is C. Moving on to question 5, we know that the following shape has 2 lines of reflectional symmetry, and the shape is drawn here. We know that MNOP is the square of perimeter 40 centimeters, and the vertices of rectangle RSTU lie on the edge of square MNOP, and that MR has length xcm. So the question is, what is the largest possible value of x such that RSTU has area 20 centimeters? So in order to solve this problem, we will first look at some elementary properties. The first line of the statement says that the shape has 2 lines of reflectional symmetry. By just inspecting this figure, we could we could guess that the two lines of reflectional symmetry are here and here, respectively. And it makes sense because RSTU is a rectangle and MNOP is a square, so we would suppose that through this arrangement, the two lines of reflectional symmetry have to be the diagonals of the square. Okay, so we then know that MNOP is a square of perimeter 40 centimeters, and that MR has length xcm. So the side length of this square would be 10, so this is 10 minus x. And because of the properties of reflectional symmetry, we could also say this is 10 minus x, this is x, this is also x, this is 10 minus x, 10 minus x, and x. So finally, we want to find the largest possible value of x such that the area of RSTU is 20 centimeters. So once we've labeled all of these edges, we would be able to say that RU has length root 2 times x, and UT has length root 2 times 10 minus x. So the area of RSTU would be root 2 times x times root 2 times 10 minus x. And that should be equal to 20. How can this be? 2 times x times 10 minus x would be equal to 20. Therefore, x times 10 minus x would be equal to 10. And we continue solving this, and we would realize that we were obtaining a quadratic equation. So we can just use the quadratic formula in order to obtain x equals to 10 plus minus 100 minus 40 over 2, which means that x is equal to 5 plus minus root 15. And since the question asks for the largest possible value of x, we obtain the largest possible value is 5 plus root 15. So that's option F. And that concludes the first 5 questions of this paper. I hope you enjoyed today's video and found the problem interesting. If you like this video, be sure to comment, like, and subscribe to my channel. Feel free to suggest problems that you want me to go over in the comments or in the opinion box, link in the video description. Thank you for your support, and I'll see you in the next video.